Okay, everyone. So this is our last section on regression. But before we begin the section, chapter 9, we just had a little bit to do finishing up on chapter 8. So what we did on page 101 was we looked at our drinking and partying behavior from survey 1, and we made these regression estimates. You know, given how much you party, estimate on the average how much you drank. And we saw there was a pretty strong correlation coefficient, and it seemed to be doing a good job here. So now let's do the same thing. Let's look at these statistics, and instead of predicting drinking from partying, which is sort of the natural way to do it, you think the more you party, the more you drink, we can also turn it around and make a regression, use this correlation coefficient and these same 4 summary statistics, and now instead of predicting drinking from partying, we can, on the next page, predict partying from drinking, and also attach a margin of error to our estimates. Remember, these estimates aren't exact, so we're going to attach a little margin of error to our estimates, known as the root mean square of the errors, the standard deviation of the errors. So let's proceed with the same data. Predict how many hours of partying someone who has 5 drinks per week does. Okay, so now 5 drinks. This is what we know. So we start off with drinks. And somebody has 5 drinks. We want to make an estimate about how much that person parties. So how many party hours? Okay, so we want to go from drinks to party hours. And we know that so far, the way we've learned it is by converting the number of drinks, which in this case is 5, to what? A z-score. So we'll do that. We'll multiply then by what? What do we multiply to get to the z-score for party hours? By R. And R is 0.75. You probably can't read this up here, can you? I just copied it from the previous page. It says the average party is 6.5 hours with a standard deviation of, I hastily did this, 6.6. And the average number of drinks in this class was 8.5 with a standard deviation of 10.7. Can you read that, or should I copy it over? Can you read it? Sorry, it's kind of messy there. Okay, so let's do the drinks. We have 5 drinks. We have to get to a z-score. So this is 5 drinks. So what do you think we're going to do? Minus what? You tell me. We're at drinks, so we're going to minus what? The average, which is what? 8.5 drinks, and then divide by the standard deviation, which is 10.7. Does everybody see that? All those drinks cancel out, and we get a pure z-score. So let's do that. It's easier on our calculator. You're going to be able to use this calculator or any calculator on the exam. I want to try to get a glare off of it. Okay, so let's just do this. So we have 5 minus 8.5. Of course, we could do that in our head. And then we divide by 10.7. And it's a negative z-score. Does that make sense to people, negative? Because it's persons below average. So we can write down negative 0.327, but you might as well, to get the accurate estimate, leave all the decimal places in your calculator. Okay, so just leave them in there and then and round at the end. It's just I don't feel like writing all the digits down here. So now, what's my next step? I have to multiply this by what? 0.75. So let's do that on the calculator. I want to try to get the glare off here. So I multiply by 0.75, which will bring the z-score closer to 0. And it does, of course. Negative 0.24 is closer to 0, so let's write that down. So we get negative 0.245. Now leave all the decimal places in because, as I'm sure you've learned in high school, it's best to round at the end. And since we're using real data now, I'm not making these numbers that round so easily, so that's why we're not doing it in our head. All right, and it's so easy to do on the calculator. What does this tell us right now? This z-score, can you see it here? This z-score, and the calculator just has the more accurate estimate. What do we want to do with that? Any suggestions? I want to change it to hours. It's a pure unit now. What does that tell me, that z-score? It tells me how many what? How many standard deviations that person is below average. So we should multiply it by the standard deviation for what? Here we are at party hours, so we want to multiply it by what? You tell me, pick which standard, it's so hard to see. But do you want to do it by 6.6 hours or 10.7 drinks? 6.6 hours, we're at hours. So we want to multiply it by 6.6 hours. And now that tells us that tells us how many hours below the average the person is in terms of partying. So that's how many hours he is below the average. So I'm trying to change this to a z-score. So I multiplied, let's just do it on here and then we'll write it in. Okay, so what should I do now? What should I add? I want to add the average. And the average for what? Partying. So we look up here, the average partying is what? Somebody said it, 6.5. And that will be the answer, 4.88. All right, so let's do that. And I made it messed up here, I'm very sorry. What this is the z-score. And I wanted to put right in here the standard deviation for partying, and I did that, and that's 6.6 hours. We did that, and then we added it to the average partying, which was 6.5, and we came out with a regression estimate of almost 5, 4.88. 4.88 hours. This looks like a demented person wrote it. Who's like, had something wrong with their hand or something. I'm really sorry. This should be what? This should be 6.6. There, can you read it now? And it's hours. That tells you how many standard deviations you are. This was our z-score, and here's our two z-scores. This is z for what? Drinks. And this was z for party. And notice how it's closer to the average. It always is. Any questions on that? Now let's get neater. All right, so what's the standard deviation of the errors for predicting partying from drinking? Do you even know what that means? What are we doing here? What I said was, okay, this fellow says that he drinks, or girl says that he drinks 5 drinks, and I'm guessing. I'm saying, okay, 5 drinks, I think it's about 5 party hours. 4.88, I'll say. So my estimate is 4.88. Would I really say that? I'd probably say about 5. But let's just say I said 4. Approximately 5, I'll say. 5 hours of partying. But give or take what? I'm not going to make an exact right on the nose. 4.88 for sure isn't going to be exact. Who's going to say, oh yeah, I drank 4.88 drinks on the average per week? You would. You're an accurate person. You keep data on that. 4.88. All right. You always leave a little bit left in that beer, you know, the last one, the 5th one. Just don't want to finish it off. Okay, so what are we going to put in here? Help me out. Plus or minus what? The root mean square error. That's your margin of error. And do you remember the formula from it? The root mean square error is equal to, I doubt whether you remember it, it's equal to 1 minus r squared times the standard deviation of y. So in this case, it's going to be the same as what we did before for r. And if you recall, this under the radical gives us about 0.66. We can do it. Let's just do that part of it. And what do we have? Let's just do the square root of 1 minus 0.75 squared. Let's just get that. And it's about 2/3 of the error you'd have if you knew nothing. If you knew nothing, you'd predict the average. What do I mean if I know nothing? If I didn't know how much this guy was drinking at all, then I'd say, I just wanted to guess how much he's partying, I'd predict the average, 0.65, and I'd be off by about 6.6. Now I know something. I know he only drinks 5 drinks, less than average. So I'm predicting 4.88 or 5, and my error is no longer 6.6. It's reduced by a fraction of that, and that fraction is 0.66. The bigger this r is, if this r was 1, I'd have no error. Okay, so times the standard deviation of y of 6.6 hours. So let's do that. And why did I choose this standard deviation? Think about it while I do the math. This times 6.6 hours. I did plus. That is wrong. What do I want to do? Times. And am I putting the right standard? I might just be fooling you. Tell me what to put in here. Should I put in 6.6 or should I put in 10.7? 6.6. Does anybody think I should put in 10.7? No, because y is always the variable you're predicting. We're saying hours. We want this to be hours here. Y is always what you're predicting, and in this case, it's hours, party hours. So this is what I want to do. And obviously, I want about 2/3 of 6.6. So let's do it, 2/3 of 6.6, and see what we get. 4.4 about. Okay? Any questions on that? Now, you're probably wondering, when does she want us to round and when does she not want us to round? Well, on the exam, it will be very, very explicit. I'll tell you exactly where, and on homework problems. So much of it doesn't depend so much of it just depends on the homework program we're using, unfortunately. And how much tolerance I can program into it, that's all. So in this last example, you had to give very accurate answers. But I want you to understand the idea of it. So we got 4.4 hours, okay? So what does that mean? That means that our estimate is about, which one do you want to use? This one or this one? Just tell me. Which one would you prefer using as the regression estimate? For now. 5. Okay, so let me just go down here, just so you can understand what we're talking about. So we predict, based on his drinking of 5 drinks, that this guy, he'd party 5 hours plus or minus about 4.4. And if we want it, what does that mean, the plus or minus? Same as what? Same as the upper limit would be about what? 9.4? And the lower limit would be what? Only 0.6. in that range. Hey, somebody who said 4.88 drinks, wherever you were, I mean, is that how much you party? About 5 hours of partying a week? I don't know. Anybody here have about 5 drinks a week? On Saturday, 5 drinks a week. So you do all your drink in one fell swoop. Friday happy hour, and then so is that the extent of your partying? It carries over longer. So it's about 5, how many, 10 hours do you party? Not straight, but yeah, you do. And how much do you drink approximately? Just 1 drink a day keeps the doctor away? Oh, 6. 6 drinks a day. Boy, that could bring the doctor in. 6 drinks a day. That's a lot. Oh. Well, all right. So, we didn't do this one. H, suppose the student actually parties 12 hours a week. Okay, suppose he actually parties 12. How far off is the prediction? So now we're doing H. And the easiest way to think about this is, okay, where's our prediction? Just think, our prediction is always on the line. And what did we predict for this? Let's just say 5 instead of 4 point. That's our prediction. Isn't our prediction always on the regression line? Now, we find out for this guy, you know, this is the y-axis, this is the x, and this is how much he parties, and this is how much he drinks. And here he is at 5, and we make drinks, and we make this best prediction for him. And then he turns around and says, hey, that's off. I really drink what? 12. So he's up here. He's up here at 12. I can't put him way up here, but this is his point. 12 hours. So we were off by how much? What's that distance? What's that distance? So that's 7 is our prediction error. That's our answer. If you just think about it that way, you don't really have to remember anything. But if you want to think about it, the definition, the prediction error is the actual minus the predicted, which is in this case 11 minus 5. 12 minus 5, which is 7. 12 minus 5, which is 7. Any questions on that? Okay. 12 minus 5, which is 7 hours. And what if he was under? If he said, oh, I only party 3 hours. Well, then it would be under, so it would be negative, under the line. Okay, I think we're good on that. I think we're good on all this stuff. And what do you need to remember here? You're going to look at this thing. I just want to help you remember. This is the formula that you're going to be using when you attach a little bit of margin of error to your estimates. And this is going to range from what? What's the smallest this can be? Yeah, the smallest equals 0 that this can be, and the largest has to be what? The largest is going to be, the smallest is 0 when r equals 1. You have no errors. No errors. The largest is when you have just, total scatter. You're predicting the average, y, and this spread here is the standard deviation of y. And that's when r is equal to 0. Just plug a 0 in there. Just plug a 0 in there, and you'll see that's the largest. All right. Let's start the next chapter. And we'll be done. Next chapter shouldn't take us too long. I think you'll like it. Okay, we've been doing these regression estimates through this process of converting to z-scores. But there's another way that we can do this, and that is just by getting the equation for the regression line. We know that our estimates fall on this regression line, right? On a line called the regression line. Well, and if we get the equation for this line, then given any x, you could plug it into the equation and solve for y, right? So you might prefer to do that. So now you'll have two methods for doing these regression estimates. So think back to Algebra 1. What's the equation for a line? Is this the form you learned it in, y equals mx plus b, where m's the slope and b's the y-intercept? Does that sound familiar? Otherwise, I'll introduce other terminology that's more statistical language. Is this familiar? Okay, then let's just stick with this one. All right, so let's start with the slope. For the regression line, we know the slope is this. Remember this? Maybe not, but in case you forget, let me just remind you why that's the slope. So you have two lines here. This is the SD line, and this is the regression line. This is the line that has the perfect correlation. If every point was on this line, then all your z-scores would match up. And if you went over one standard deviation in the x direction, you'd go up a full standard deviation in the y direction to the point 1, 1. We know for the regression line, that's not what we do. For every standard deviation, let's say it was a z-score of 1, x has a z-score of 1, to get the z-score for y, we multiply by r, which brings us closer to the average. We don't go up a full standard deviation. We have a mixture of going up to a perfect correlation. If r was 1, or if r was 0, we just predict the average. And R basically tells us what that mixture is. The stronger R is, if R was 1, then we'd go all the way up. If you have a z-score of 1 in x, you'd have a z-score of 1 in y. If you had a z-score of 2 in x, you'd have a z-score of 2 in y. And every point would be on the standard deviation line. If R was 0, you'd have complete scatter here, and you would just, no matter what your z-score was, you just predict the average. So this really tells us the slope. The slope of the regression line is what? Just look at this. The slope of the regression line is equal to what? You can just see the picture. Is equal to what? First of all, it's rise over run. So if we run, the easiest thing to do is to start at the point of average of 0 and go over one standard deviation in the x direction. Then, what is that rise? It's not a full standard deviation in the y direction. That would take us all the way up to there. It's not. You always multiply, you don't go so far. You always multiply by r. So that is the slope of the regression line. We already have that. By the way, if you forget the slope of the SD line, the slope of the SD line, the slope of the SD line is what? What is the slope of the SD line? If you went over one standard deviation in the x direction to a z-score of 1, to get to the SD line, you'd have to go a full standard deviation in the y direction. Okay? Now, so we know this. If you're in z-scores, it's so easy because the standard deviations in z-scores are 1. So if I converted everything to z-scores, the point of average would be 0, and the slope of the SD line would be 1, and this would be r, the slope of the regression line. But we're not usually in z-scores. Okay, so any questions on this? By the way, what does r look like to you to be here? How can you determine what r is here? I say the close Look at this. I say R tells you what mixture you are between having no correlation, and your prediction would be a horizontal line, and a perfect correlation. So you just have to think how far up. I'm just going to make a similar triangle just over here. So if this is 0 and this is 1, where does this line cross? Just mark it off into tenths, let's say. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. What does this look like to you? 0.5, 0.1, 0.2, 0.3, 0.4, 0.5. Do you see what I'm doing? That would be 0.9. So R, in this case, in this picture, in this scatter plot, R is approximately 0.5. If R was 0.9, it would be way up here. It would intersect, it would be a very steep, much steeper line. If R was 0.1, it would be a much flatter line. All right, now it's time to do these problems, okay? Questions?
Do we always assume that the graph is to scale?
Do you always assume the graph is to scale? It doesn't matter if it's to scale. Do I always assume the graph? If I'm asking, do you mean?
Because you just ticked off 0.1, 0.2, 0.3,
Yeah.
If it's not to scale, that's not going to help us, right?
Yes, it will still help you because it's scaled relative to the SDs. It might not actually be to scale. Her question's very good. This might not be to scale. A lot of my graphs aren't to scale. But that it's scaled, it is that relationship between R, the regression line, and the standard deviation line will still be to scale, even if the rest of it isn't. It might not be scaled, yeah, good question. Okay, so now we're ready to do the same, to get this regression estimate. First, let's just see what the iClicker was about, though. So let's go to get your iClickers out. I just want to make sure you understand everything so far. Before we even do these regression estimates, let's see if you understand this. So I'll start this here. Which is the regression line? Can you even read this? You can't read this. Let me just see if I can make it bigger. The far right corner, yeah. Does that help? Does that help? It says, which is the regression line? Okay? If you think it's line 2, write B. If you think it's this flatter line, write B. If you think it's the steeper line, write A. This is A, steeper, flatter is B, and all I'm asking is the regression line. All right, can I stop it? All right, let's see what you did. You got it. Okay, let's do the next question. The next question, I'm going to start it right now. It's where is, can't even get it. Let me just go down a little bit. What line is the point of averages? Okay. What point is the point of averages? Can you see this well enough to know where the point of averages is? These will be on your exam, these type of questions, so I just want to give you a little preview. And the exam's coming up when? On Wednesday, is it 2 weeks from yesterday? 2 weeks from yesterday, less than 2 weeks. Okay, so let's stop this, look at this, and the point is B. Y'all got it, great. All right, now let's look at the next one. How about if we just do this one? Estimate R. Can you estimate R? Your choices are here. And let me move this out of the way. You're comparing the steepness of those two lines, and we're doing number 5. I'll start it for you. And this is the one we're doing right here. And you're trying to compare the steepness of these two lines. Is it 1, negative 0.6, 0.3, 0.6, or 0.9? What do you think? 2 of these you can eliminate right off the bat. See if you can get this one. I'm curious if you can get this. Questions? Oh. Okay, can I stop it? I'll stop it. Let's see what you wrote. The answer should be D. Oh. Let's see, why? Do you see it's the same picture? I just drew a little, maybe it was hard for you to see it, but where'd it go? One down. Maybe it was hard to see. The point is just to understand the idea of it, all right? So let's go back to the overhead and now figure out how to get the slope of the line and then the intercept, and then we'll be done. Okay, so let's use that same data that we had last time and see if we can get the equation of the line. All right, so let's fill it in. We had 6.5 hours here, 8.5 drinks, 6.6 hours, and 10.7 drinks, and R was 0.75. So let's just make the same regression equations and see which way you prefer it, okay? So the very first thing that you want to do is what? What's the first thing that you want to do? You want to find the slope, okay? So first of all, just remember what the equation of a line looks like. We're estimating drinks, so which one should be Y? I mean, we want Y equals mx plus b, right? But we're not given Y and b, Y and x. So which one's Y? Is drinking Y or x? Whatever you're estimating is Y. So that has to be x. Whatever variable you're predicting or estimating is always Y. Okay, so this is drinks. So it's going to look like this. Drinks, the number of drinks is going to be equal to something, which will be the slope, something, that's m, we'll put our slope in there, times party, because that's x, times party plus something. And what's that something going to be? Right in here. The y-intercept. So that we just have to fill in those two blanks. Now first find the slope. Okay, so you first find the slope, and we already remember what? How are you going to remember this? The slope is equal to what? If you, let's say it's an exam, you just completely forget, you completely blank. Slope. Do you think you could remember that it's going to be that you multiply by r to get from one z-score to another? The slope is going to be r, and then it's going to be a ratio of 2 standard deviations. 2 standard deviations. And do you think it's going to be y over x or x over y? Y over x, rise over run. If you went over 1 standard deviation in the x direction, you wouldn't go up a full standard deviation in the y. So that's your slope. Any questions on that? So you'll need to remember that, but it's not that hard to remember if you think logically about it. And r is given to you, 0.75. And now we just have to decide, is it going to be 6.6 over 10.7 or 10.7 over, those are 2 standard deviations. So which one is y? Is what, does everybody, it's going to be drinks per hour. Drinks is y. So put 10.7 on top, and then we have 6.6. And that's all you need to do. Any questions about that? And it might help. Sometimes, in this case, it really helps if you put the labels in because it's drinks per hour. So it's going to tell you how many drinks, it's going to tell you how many drinks per hour. Okay, so drinks per hour. So let's do that on our calculator. And what do we get? We get 0.75 times, I hate this glare, 0.75 times what? 10.7 divided by what? Divided by 6.6. And we get 1.21590. How about just 1.2? Just 1.2? Okay, 1.2. All right, I'll tell you how much to round by. So what does that mean? That means for each extra hour of partying, you drink about 1.2 more drinks. That sounds about right. Now, we have to get this y-intercept, which is what? It's how much people, when partying is 0, when you don't party at all, or maybe before you go to the party at 0 hours, how many drinks you have. Okay? So far, what we have is 1.2 y. Now, to find b, the y-intercept, you can do this lots of different ways, but I think the easiest way is just to think about what you have. You have drinks, so far, equals 1.2 party hours plus something. And you can see when you have the drinks per hour, those cancel out. All right, so we're just trying to get this. Now, this is an equation for a line, so it's true of every single point on the line. So if you know any point on the line, if you know any point at all, you can plug this in and solve for b. Do we know any point on the line? What point always is on the line? The averages. So plug in point of averages. So plug in the average drinks here and the average party hours here, and we'll be done. Any questions on that? So if we plug in the average drinks, what is that? Look up here, and what do you plug in? So we have 8.5 drinks equals 1.2 times the average party hours, which is what? 6.5 plus b. And we just want to solve for b. That's all we have to do. The labels cancel. Any questions on that? So I don't have an extra line, so I'll just say, I'll subtract. So what is b? Should we subtract this from both sides? So should we subtract this from both sides? Okay, I'll do that. So I'll say 8.5 to get b, clear. I'll just say 8.5 minus what? 1.2 times 6.5. And I get 0.7. So that's my answer. So B is equal to 0.7. So I can put it right there. So B is equal to 0.7 drinks. I just subtracted that from both sides. You can check your work and make sure, that when you put a 0.7 in here, it all adds up. All right, so now we have any questions so far? So let's write our regression equation. The number of drinks equals 1.2 times your number of party hours plus 0.7. Okay? That is your equation. Any questions on that? And now let's see what did we do last time? Did we do 20? And we got 20, we plugged in 20 on page 101, and we got 24.91, 25. Let's see if we get the same thing. So now for 20 hours per week, we'll say 1.2 times 20 plus 0.7. And we can do this one in our heads, right? So what do we get if we do that? You don't want to do it in your heads? Okay, clear. So we do 1.2 times 20, enter, plus 0.7. So it's 24.7. And last time, we did some rounding here. Last time we got something very, very similar. We got what? We got 24.91. We were more careful here. We didn't do so much rounding. All right, so you can do it either way. Any questions on that? How well does the regression equation predict your own drinking behavior? What's your residual? Do you want to do that? Anybody want to volunteer to see how well the regression equation works on them? Anyone? No? You want to just move on? Okay. All right, you can just do that on your own, in privacy of your own house. Okay, so now we're going to go in the other direction. Now we're going to see that the regression of y on x and x on y aren't the same thing. We've already seen that before, but now we're going to see that they're different equations. So now find the regression equation for predicting. We'll go back to the mothers and sons examples, and we'll go back and forth. Okay, so let's do this one. So for predicting sun's height, so here sons are y. This is the same example we did in both directions, so let's look at this. But before we do this, do you mind, I'm just really curious how close we got to our own data, to what they said in the program. So let's just pull it up, and I just want to see what it got on the here. So let's just go to survey 2, what was it? Spring 13. Survey 2. And let's just go to our scatter plus. I want to see if we got the same thing as what is up here. So if we first go to party and drink. And look at this regression equation. I don't know if you can see it, but it says that the number of drinks per week equals 1.223 party hours plus 4.764. So we did some rounding there, and the root mean square error is 0.7. We did some rounding there. And if you go the other way and flip it, let's see, we get drinks per week and party hours. Interesting. It's a different equation. Okay, so now let's go back to the overhead, and let's just finish this up, and I think we'll be done. So we're going to leave here early today. Okay, so let's look at this example. All right, so this is, just to get you ready for the exam. If you do it now, you won't have to study so much. What if I say you had to find this regression equation? What would you do first? You'd first find the slope, right? You first might think, what is an equation for a line? Y equals mx plus b, because you already know that. And then you'd say, okay, sons are y. So you'd say son's height is equal to something times the mom's height plus something. And first you want to get the slope, and then you want to get your y-intercept. All right? So how would you get the slope? First you want to get the slope. See if you can write down the equation for it without looking back. See if you can do that. Actually, this is a pretty easy one. You could solve for this pretty easily. You can do this one in your head. Okay, so drawing a complete blank here, right? You're going to know it's something over something, right? Aren't you? I mean, first you're going to know r. Are you going to remember it's r times something? Can you remember that? And then it's the ratio of two standard deviations. And is it y over x or x over y? It's always y over x. So if you get this far, all you have to do is look up here. You're given 0.5 is r, and now you've decided that whatever you're predicting is y. So look for the standard deviation. Sons are y. So 3 over 2. It has to be. Does everybody see that? Does everybody see that? So that's 0.75. So you stick that right in here. How many people got that far? Now, what's our next step? Let's just write it out so you don't forget it. To find the y-intercept, you can do it lots of different ways. You don't have to follow it this way. I'm sure you can, you can do it other ways too. But I think the simplest way to remember it is to find the y-intercept, you just plug in the point of averages. That's all you have to do. You have this, you know now that sons are equal to 0.75 moms plus b. And you want to get b. So all you have to do is plug in that point of averages. So write it underneath. What's the average for sons? Just write it down. And what's the average for moms? Just put those numbers in. Just look up at the table and just read it correctly. Here's your averages for sons, for moms. For moms, what is it? So now all you have to do is get that b. So you want b standing alone here. So you just subtract this from both sides of the equation. You want b standing alone. So when you subtract this product, you get b, and now subtract it from here. So let's do that on our calculators, and we get what? 69. All I'm doing is taking 69 right there. And what do I want to subtract? That. So it's minus 0.75 times what? What does that say? 65 times 65. And that'll be my answer. 20.25. So that's what b is. Okay? So we solved and we get b is 20.25. And we stick it right in there. That's our equation. Any questions on that? It's pretty easy. Now, if we want to use this equation to predict the height of a son whose mom is 69 inches, we'll just say how tall. Okay. So we'll say son is equal to 0.75 times the mom is 69 inches plus 20.25 and see what we get. See if we get 72 inches like we did last time. Did we do it? Did I do everything right? So let's just try it. So let's just do it. So you go 0.75 times 69 plus 20.25. We know we want 72 and we got it. Because we got it both the last, the other direction, the other way. We didn't do so much rounding because I made up these data to be nicer. And on our exam, I'll try to make the numbers work out better so you'll get the exact same thing whichever way you do it. You have questions? Questions? This is a multiplication sign. Okay, now I want you to try this one. You have some time. Work together and try this one. It's not going to be the same. Why is it not going to be the same? Because what are you predicting now? Mothers. So see if you can just follow the same thing and just do it. It will help you. And just do C and D right now. I'll give you just a few minutes and then we'll go over it. And then we'll just leave and that'll be it. And then we'll be done with regression. And I'll post your homework pretty soon. If you have a question, just ask. Let's go back and make sure everybody gets this. And now mothers are Y. So what are we going to do? If mothers are Y, we're going to have mom's height equals something times the son's height plus something. All right, so we want that slope. And the formula is the same. It's r times the standard deviation of y over the standard deviation of x, which is 0.75. But what's changed? The y and x have changed. Now moms are y's. So instead of 3 over 2, what do you think I should put in here?
0.5.
Oh, shoot. Where did I get the 0.75? Was that from our last example? Yeah, 0.5. But now, instead of 3 over 2, what should I put in here? 2 over 3. So that's 1/3. Now we have 1/3, and we just need that. Does everybody agree? Everybody agree? So now, this was our first step. Our second step is what are we going to do? we're going to plug in the point of averages. So can I just do it right here? What's the mom's average? 65 inches is equal to 1/3 times the son's average plus B. And now I want to subtract. All I'm doing is subtracting from both sides. The 1/3 69 inches from this side, so B stands alone, so I have to subtract it from this side. And let's do that. So you just take your 65 inches, right here, 65, and you minus 1/3 of 69, which I know in my head is what? 23, right? Minus 23, and I get 42. Okay, so that is the answer. Right there is your equation. Any questions on that? And now, please don't leave yet. Please. You still have a lot of time. Don't leave. And now, what do we want to do? We want to see what happens when we put 72 in. So we have our equation. Moms equals 1/3 sons plus 42. And now when we put in 6 feet for the sons and add 42, we don't get 69. What do we get? 66 inches. That's how tall. So that's another way to show that the regression of y on x and x on y are not the same thing. Now, let me just see what else we have to do here. That's it. And so we're getting out early today, and I'll post your homework right away.